Hello everyone, myself again, Dharan Sai, so faculty of Machine Design at ACE Engineering Academy. So today we'll be seeing some important concepts related to this subject. So I have chosen the topic to be static loading, and so it's been for many years. So it has been kept as a secret from this particular chapter. So I'm going to unveil this particular secret from this chapter. It's not only for this particular chapter that this is a secret that has been hidden for many decades. So which means if you understand this secret, yes, you can understand what is happening in this subject. Okay, so let me unveil what is the secret here. Before proceeding, I would like to give some important points. What are they? We know that we have some experimental analysis. Let me assume that we have a component. Let me assume that this is a component that we have, and this component is loaded. If this is loaded, yes, due to loading, yes, the particles inside this component will also be under loading. If I assume that this load is P, if I consider a small element in the system, this simple element will be taking a load of sigma. Okay, and during the course, you might have understood that this value of sigma under axial loading is nothing but P by A. It is P by A. Yes, here we'll be having multiple particles in the system, and I hope so you might have gone through the critical section due to loading, and here we are assuming that, see, if there are a number of particles in that particular section, yes, on an average, if there are a number of area number of particles, on an average, on the surface of each particle, the load which is acting is P by A. This is the load which is acting on the particle. Now, this particle is made of some material. As it is made of some material, yes, from experimental analysis, we'll be identifying its capacity. There are two different types of materials. One is ductile material, another one is brittle material. We know that in case of ductile material, there is large amount of plastic deformation before fracture, whereas in case of brittle materials, there is very small amount of plastic deformation before fracture. As plastic deformation is considered to be the permanent deformation, yes, when it is undergoing, when the component is loaded into this region, it is getting damaged. Permanent damage is happening. If that is only within the elastic region, there is no permanent damage. Yes, our component should not get damaged. This is what is our interest. So what we do, that can be either ductile component or brittle component that has to be loaded only within the elastic region. So the dividing point between elastic region and plastic region is considered to be the failure point. Yes, in case of ductile materials, experiments, yield stress is identified. Yield stress that can be in tension or in compression or in shear, this stress is identified. For a given material, yes, we know that at what value of stress it is entering into plastic region, which means if the particle is loaded beyond this value of stress, that will be entering into permanently damaging region. But the component or the particle should never enter into permanent damage region. That has to stay in the temporary deformation region. For that reason, the maximum stress that this particle can take, that you can apply on this particle, will be yield stress. This is coming from experiment. Now you are loading this particle. As you are loading this particle, remember that the value of stress which is coming on this particle should always be lesser than this stress. Only in such situation that will be staying within the elastic region. If I consider the material to be linear elastic in nature, if that is linear elastic, if I plot the graph between sigma and epsilon, we are assuming that, yes, in this subject, we assume that the material is linear elastic, which means in elastic region, it is behaving linearly, that is stress varies linearly with respect to strain. Is that what we are considering? Yes. Let me assume that beyond this point of stress, that is entering into plastic region, that is entering into, we have got more amount of plastic region. Okay, so finally that may undergo fracture. So this is a kind of material where there is no yielding phenomenon. Now here, this is the point where it is trying to enter into plastic region. So here, if at all if you are applying stress on this particle, so on this material, you need to apply only below this stress. Let me assume that its value is represented as SYT. We know that when particle is loaded, that will be loaded from 0. 0 in between SYT, which means your value of stress, this value of stress can stay within the range of SYT. So which means 0 less than or equal to sigma lesser than or equal to SYT. In such condition, the particle is safe, component is safe. Remember, if the particle is safe, the component will be safe. If the component is safe, the machine will be safe. If the machine is safe, yes, obviously the system is considered to be safer. Is that right? Any doubts here? Now, for keeping the system to be safer, now we need to protect this particle. Now we should not load over this particle beyond a value of yield strength. I am considering the material to be ductile in nature. Now here, what is the secret that is hidden? Let me unveil the secret here. I hope so this simple detail is, so you understood this simple detail. Now, I am going through the analysis as we need to design the member. We know that. So what is the area of the component that is required? Now here, we are giving some safety factor to this system. Here, I am going to classify factor of safety. So you might not have heard about the classification of factor of safety, but we'll be seeing the classification of factor of safety. How many types of factor of safety do we have is what is our concept today. Types of factor of safety. See here, factor of safety. Safety is measured in terms of some factor. Safety is measured in terms of some factor. Yes, in what stages we are considering factor of safety? During manufacturing of this component, obviously we assume some safety factor and then we design the member. Is that right? So here we know that the particle should not cross the value of SYT. Okay? And we also know that the stress on this particle is nothing but equal to sigma is equal to load by area. Remember that there will be some requirement by the consumer or the customer. Based on the customer need, the manufacturer designs the component. If I say that my component should withstand a load of 10,000 newtons, I am saying this is the capacity that I wanted. Minimum of 10,000, obviously it has to withstand a load of 10,000 newtons. Okay, I said to my manufacturer that it should withstand a load of 10,000 newtons. Now he'll be asking, sir, do you want one factor of safety or multiple factors? Do you want more factor of safety or less safety? Now here, so he is asking us, do you want more safety or lesser safety? Corresponding to that, if you say, yes, I want more safety, then what he'll do is, as we know that the stress should range from 0 to SYT. Now he'll assume that the stress on this particle that we have for the component, as there is particle in this component, this particle, over this particle, he assumes that the stress is never going to cross a particular value. Suppose SYT value is 100 megapascal. 100 megapascal. Now what he assumes is that, see, if that reaches 100 megapascal, the particle fails. But he assumes that, the manufacturer assumes that the stress is only allowed, this value of stress is only allowed to reach 50 megapascal. It is only allowed to reach 50 megapascal, which means you are operating the stress only within this space. It can reach a maximum value of stress as 50 megapascal. Now here, so between these two, see here, this is the capacity of particle, maximum strength that we have for the particle, and this is what is the stress, maximum stress that you are allowing. So depending on these two values, now he is going to design the component. Now corresponding to this, he'll design, observe carefully. Now as I say, this value of stress, here I can say that this stress, the stress which is allowed is half of this value. I can say that this is nothing but equal to 100 divided by 2. 100 divided by 2. Now I can replace this by a simple parameter called N. Simple parameter called N. We know that the stress equation is load by area. See, with change in load, obviously the stress will increase. Here this is the maximum stress that it can reach for a maximum value of load. From here, we are getting some relation between area and factor of safety. Now can you please say me, if this number is increasing, what is happening to area of component? What is happening to area of component? Is that increasing? Yes, the area of component increases. If you want more and more safety, which means you never try reaching this failure stress. Remember that if you are increasing your safety, which means the safety is represented in the form of number, if you are increasing this safety, you are increasing the area of component. Are you increasing the area of component? Yes. If you are increasing the area of component, yes, the component becomes more and more stronger. Is that right? That's the reason why a bus is more stronger than a car. Which one is stronger? Bus is stronger. Now recently, the recent trend that we have, if you compare the cars, the automobiles, yes, the safest cars that we have or which possess high build quality are from Tata nowadays. Is that right? I'm not going to comment on the unsafest cars. I'm only commenting on the safest cars which takes more material. Yes, they have got good build quality. As they have good build quality, which means they are using more and more material in those machines. Because of that reason, yes, they are becoming much stronger. Is that right? Remember that. So this is there in the hands of, this safety is there in the hands of manufacturer. In whose hands this factor of safety will be present? Manufacturer. So I call this as, first factor of safety is manufacturer or design factor of safety. Which factor of safety? Design factor of safety. Remember that whenever in examination factor of safety is given, which means he is asking that, he is asking you to design the member now. Now here, once the factor of safety is given as 2 or 3 or 4, that can be any number, remember that he'll be asking you to find the dimensions of the component. If you are considering more and more factor of safety, remember that you'll be considering more and more dimensions to the component. More and more dimensions, more and more stronger. I can say that the strength of this component, if I speak of tensile strength, the same tensile strength of component, the maximum load that can be applied on the component Ft is nothing but equal to capacity of particle into area of component. Remember that the strength of component increases with increase in area. More and more area that you are taking for a component, more and more load that it can withstand. This is the simple point that you need to keep in mind. We call this as designer factor of safety. Whose factor of safety is this? Designer factor of safety. This is there in the hands of manufacturer. Okay, sir. We understood this simple point. That's wonderful. Now, what is the other type of factor of safety that we have? Okay. The manufacturer has designed the component and he said that, okay, he considered some area to the component and then he has designed this particular component. Okay, now here he is saying that over this component you can apply a maximum load of Ft. So Ft can be 20,000, 30,000, 40,000, 60,000 or 1 lakh, that can be any value. Now he is saying that this is the amount of load that can be applied on this component. Now the manufacturer manufactured and he gave it to you. Now you are the consumer who are using this component. As you are using this during your usage, while using this, you may load this component or you may not load this component. So in previous days class, in yesterday's class, I have spoken something about safety. Suppose you have bought a car and you have kept this car at home. How much safer the car is? Obviously that is never going to fail due to loading. Is that right? If at all, if you are manufacturing a component, if you are making use of it, then it fails, right? It fails at some point of time during usage. But if at all, if you are not using, how can that fail due to loading? So remember that. If a component is present, if a component is manufactured, and if that is there with you, if you are not loading this component, which means that is never going to fail, its safety is infinite. Suppose you started loading this component. Now here I can say that the capacity that we have for this component is Ft. Ft is the maximum load that you can apply over this component. I can say that load applied should always be lesser than or equal to, remember that. So the load, this is the applied load. What is this? This is applied load. Applied load. This applied load should always be in between 0 and Ft. Okay. Remember that. So if the load on the component is 0, which means that is completely safer. You are increasing the load, increasing the load, increasing the load on the component, which means you are completely nearing to failure. Is that right? Let me assume the same graph here. If I consider the same graph between load as well as deformation, here the graph is like this. It is linear variation. Now here, as you are loading the member, I can say that this is the failure point. See, if you started loading at this location, if you are increasing the load, increasing the load, increasing the load, increasing, which means you are nearing to failure. As you are nearing to failure, your safety is decreasing. Now here there is one more factor of safety called loading factor of safety. What factor of safety? The second one is considered as loading factor of safety. See, this is actually present in the hands of user. Whoever is using it, so in the hands of user will be having loading factor of safety. So it says that, okay, what is the equation for this? I can say that we have some capacity of the component. I can say that it is strength of component, strength of component divided by applied load. Remember that if you are increasing the load on this component, remember that applied load is increasing, and if this strength of the component is not going to change. This is Ft which is remaining constant. If denominator increases and that reaches Ft, as the component fails. Which means for this case, under loading, I can say that factor of safety is ranging from, for this case, factor of safety is ranging from, so initially it is infinite. Is that infinite initially? Yes, if applied load is 0, I can say that when 0 load, the factor of safety is infinite. I can say that this is greater than or equal to 1. When load becomes equal to Ft, factor of safety becomes equal to 1. Can you please say me what is the meaning of factor of safety less than 1? See, it is also possessing some meaning, right? So what is the meaning of that? Factor of safety less than 1 means the component already crossed failure, that has entered into damaging region. It has already undergone some damage. Permanent damage has already occurred over this component. It is what is the meaning of factor of safety less than 1. So this is possible under loading condition. If you are loading, yes, factor of safety may go less than 1. See how beautiful the concept is. If you understand this concept, yes, each and every topic will be beautiful. I hope so you are getting the simple concept. Let me see. Okay. So I hope so you are getting this simple concept. I hope so you are getting this concept. Okay. Now let's understand. So let's understand what is the third type of factor of safety that we have. The third type of factor of safety which we have is theoretical factor of safety. Okay. Here we need to understand what is this theoretical factor of safety. We know that under combined loading condition, we do not have any experimental setup to identify what is a failure stress. So what we are doing, we are relying on some of the predictions that are given by some scientists. So that the prediction can be from Rankine, or that can be from Gust, or that can be from Saint Vannin, that can be any prediction. So here, if we are using some theory, we'll be getting some factor of safety. Okay. As we have various theories here, so according to first theory, which is maximum principal stress theory or Rankine's theory, what is he saying? He says that first you please identify what is a critical particle. After identifying critical particle, the load on this particle or the stress on this particle should not cross the capacity of particle. Oh, which means he says that according to Rankine, the failure condition that we get is when maximum stress is becoming equal to if that reaches capacity of particle. Capacity in the sense failure stress. What is failure stress? We know that yes, when stress goes beyond SYT, yield strength, that is entering into damaging region, which means on the other side we have got SYT. He says that the maximum stress that is on the particle should always be lesser than or equal to SYT for a safe operation. Okay. Based on this, yes, under combined loading, we may have more than one principal stress. Okay. If I assume that the third principal stress is 0, we'll be having 2, sigma 1, sigma 2. If I plot the possibility of sigma 1 and sigma 2 on graph, the graph will be represented in this manner. This is according to Rankine. This is according to Gust. Now, what are these graphs representing? Observe. If you observe this carefully, let me assume that there is a point here. See, we are assuming that we are loading in x direction as well as in y direction. Okay, as we are loading in x direction as well as y direction, that is in first direction, two principal directions as we are loading, let me assume that the final stress on the particle in x direction is 100 megapascal, in y direction is 50 megapascal. See, as we are reaching 150, as we are applying load, we apply in such a way that the ratio of the stress that we have on x plane, that is in x direction, and in y direction, that remains the same. Here, as we have this to be the particle, this is sigma 1, let me assume, this is sigma 1, and this is sigma 2. See, if you consider the value of sigma 1 to be 100 and sigma 2 to be 50, obviously we need to reach these values from 0 itself. As you are reaching this position from 0, see here, always the ratio of these two stresses is kept to constant. Okay, what is the ratio here? If this is 100, this is 50, sigma 2 divided by sigma 1 becomes 1 by 2. So keeping this ratio constant, will be applying load gradually to reach that particular point. So initially the load is 0, we are applying the load, and then we have reached this point. Now here, even if you increase this load to further more extent, which means even if you are increasing the load, finally you can only reach up to this position according to this theory. See here, let me assume that this value is, if this is 150, so this is, let me assume that this is 200 and 100. This is 200 and 100. So which means, for this particular ratio, for this particular loading condition, yes, you can only reach up to this particular state of stress, up to this particular position. Beyond that, see here, this is considered to be the combination of, it is considered to be the failure stress according to this theory. He is considering that as a failure stress. Beyond this point, it is entering into plastic region according to this theory. So if that is staying within in this region, yes, that is safer. Suppose if you are assuming that, okay, so it is falling, the ratio of sigma 1, sigma 2 is different. In such case, yes, that will be following another line. That will be following another line. The line may be like this. If sigma 2 is greater than, or here, if you are assuming in that manner, sigma 2 to be greater than sigma 1, in that case, obviously, we'll be getting a graph in this way. So in such a situation, yes, this is the failure point, which means whatever is the point that we have here, sigma 1, sigma 2, yes, sigma 1 value should not cross this value, sigma 2 value should not cross this value. If that is crossing, yes, the particle is reaching failure. This is what is said by Rankine from his graph. Now if you observe carefully, as this is the failure point, this is the failure point, the more and more you load, you are reaching nearer to the failure point. As you are nearing to failure point, yes, let me assume that this distance, whatever that we have, this is representing factor of safety. More the distance, more the, so if this point is located here, which means it is, in terms of loading, yes, this is more safer. So if you are increasing the loading, the distance between this point and this point is decreasing. Because of that reason, the safety is considered to decrease. As the safety is keep on decreasing, once it reaches this position, it fails. The particle is assumed to fail according to this theory. It is simply a prediction by Rankine. Similarly, if I consider Gust theory, that is maximum shear stress theory, if we observe carefully, the boundary that we have in first quadrant is remaining same. The boundary that we have in first quadrant is remaining same. That is remaining same according to both the theories. Whereas the boundary that we have in this region, मान लो, I am assuming this particular region. So this yellow line represents the boundary of maximum principal stress theory, Rankine's theory. This is the boundary of maximum principal stress theory, which means he says that if you are loading the particle, under combined loading, so you are entering into this region, right? Let me assume that it says that you can go up to this position. After this position, yes, he says that the particle is reaching failure. It is just his theoretical analysis. This is simply his prediction. So that is a prediction that was given by Rankine, which means the combination of sigma 1 and sigma 2 should not cross this point. If that is crossing that point, it is failing. Let me assume that the stresses on this particle are now operated at this location. See, I can say that this is the failure point. This is the failure point according to shear stress theory. This is according to maximum shear stress theory. And this is the failure point according to maximum principal stress theory. Now, if you observe carefully, the operated point. So this is, let me assume that this is the point of operation. The point of operation here, this is very closer to the failure stress that is considered by maximum shear stress theory. Which means this is the safety factor that we have according to factor of safety that we have according to maximum shear stress theory. Whereas, if I consider the safety that we have according to maximum principal stress theory is this. This is the safety according to maximum principal stress theory. Now, can you please say me which safety is larger? See, whose prediction is giving more factor of safety? See here, when we are considering predictions, we need to see the safe prediction. We want the safe prediction. Remember this always. See, for safe prediction, observe, among these two, as this is considering lesser failure stress, always remember that lesser stresses are more safer. More stresses are less safer. As here, it is considering, as maximum shear stress theory is considering lesser failure stress, that theory is more safer compared to maximum principal stress theory. Which means here among these two, the safest theory is maximum shear stress theory. As maximum shear stress theory is safer, I can say that for safety, as we are getting two different factor of safeties, factor of safety according to maximum shear stress theory, factor of safety according to maximum principal stress theory. Remember that among these two values, we need to choose the minimum value always. For safety, factor of safety is nothing but equal to minimum of these two values. Remember that this is the theoretical safety, theoretical factor of safety that we have got according to shear stress. This is according to principal stress. See, for the same loaded point, the point is loaded the same in both the cases. But here, according to his prediction, it is more safer. Why? Because according to his prediction, he is considering more failure stress. As he is considering more failure stress, the loaded point is very far away from this failure stress. That's the reason why he is giving, that is, Rankine is giving more safety, more factor of safety, that's it. But for safety, here I can say that among these two, the safest design that we have is from the least factor of safety. Remember that in examination, if equation is asked on this topic. Now here, I am going to make some analysis. Here if you observe carefully, in first quadrant, as boundary is the same, failure stresses are same according to principal stress theory and shear stress theory. Which means either you use principal stress theory or shear stress theory, both will be giving you same safety factor. Remember this simple point. When sigma 1, sigma 2 are like in nature, meaning of like in nature is, so when sigma 1, comma sigma 2 are like in nature. Remember, when sigma 3 is equal to 0, this condition is only valid when sigma 3 is 0. I can say that when sigma 1, sigma 2 are like, I can say that factor of safety according to maximum principal stress theory is equal to factor of safety that we get from maximum shear stress theory. Both are same. But when sigma 1, sigma 2 are unlike, unlike in the sense one is positive, other is negative, like we are getting in second quadrant and fourth quadrant. Only in those quadrants, remember that factor of safety according to maximum principal stress theory is greater than factor of safety according to maximum shear stress theory. Among these two, remember that always the least value is safer. This is the safest value, safest. Always, if you are comparing between theories, the least value of factor of safety is safer. See, this is what is the hidden concept that we have in this subject. Yes, finally I have unveiled this. Yes, as you can see that factor of safety, as I said, it is classified into three different types. One is designer factor of safety, where the designer gives what is a safety factor. And then corresponding to this safety factor, yes, we are going to manufacture the component by increasing the area of component. After designing, yes, that is there in the hands of consumer. Yes, the consumer can either load or he may not load. That is his choice. So depending on the load that is applied on the component, yes, again we are getting loading factor of safety. More and more the load, yes, I can say that lesser the factor of safety. Is that right? Now here, the last one that we have is theoretical, where it is based on some predictions that are given by some scientists. See, each and every scientist considers different failures. Just because of that reason, yes, each and every scientist is giving different safety factor. But the most safest one is always the least one. Always the least one. Keep this point in mind. Yes, the same analysis is even used in second chapter. That is, if we are considering modified Goodman theory, there are two theories to be used. Remember, that can be either Goodman or yield line theory, which is considered as Langer's theory. Among these two theories, remember that, so find factor of safety based on both the theories and use the least factor of safety. If Goodman is giving you a factor of safety of 2.5 and yield line theory, that is Langer's theory, is giving a factor of safety of 2, remember that among these two, according to modified Goodman theory, you need to choose the least value. It is not the largest value. Always keep this point in mind. Okay, I hope so this is clear. Is this clear? I hope I have given you a wonderful concept. I hope you have got the concept. Any doubts regarding this? So like this, there are many cases, many concepts in this subject. What you need to do is that you need to pay some attention. If you pay attention, yes, you can understand this content very easily. I can say that this is the easiest subject. See, if you understand, conditions always apply. So don't generalize. Remember, as I said, this is easiest. Condition is if you understand. Yes, if you understand, not only this subject, any subject becomes easier. You need to make it very easy so that your preparation becomes easier, so that in examination you take limited time, very lesser time for solving a question. See here, we are here to learn, crack exam and then move. We are not here to do PhD works. Is that right? So here, it's my request, so you better observe, understand and proceed further. Don't do PhD work here. Okay, if at all if you want to do PhD work, later in the next stages, you can do that. Okay, I hope so. You got this content. Let me see whether you have any doubts or not. Okay. So I hope PDF will not be available for this. But what I suggest is please try to take down the notes. So whatever I have said, discussed. Remember these points, these are the golden points where no one teach you. No one ever gonna teach you these golden points. So these only comes from observation. Only if a person observes the subject to the core, then only he can identify this golden topics, golden content. Yes, I can say that, yes, many can teach content, but only few can observe the content. Okay, please do observe this content. If you can observe, if you can understand, yes, this becomes easy. Okay, So with this, I would like to close this session. I hope you enjoyed this session. So please do share this topic with your friends. Okay, if you want to share, please do share this topic with your friends. I wish you all the best. Take care. Bye bye.
I am Nikhil Kumar Saha. I got AIR 1 in Gate Mechanical 2022. I was enrolled in ACE online test series program. So test series, whether it would be subject wise, topic wise or full length test, it helped me to improve my numerical solving skills in all the domain of the subjects that are included in mechanical. It helped me to cope up with the new numerical type of problems which normally students face difficulty in solving in first go. So it helped me to cope up with this type of numericals, and also I got to know through different multiple choice questions, multiple select questions which are now in the Gate Mechanical they have introduced. So I got very good quality questions, so it helped me in preparation a lot. I am Nikhil Kumar Saha. I got AIR 1 in Gate Mechanical 2022. I was enrolled in ACE online test series program. So test series, whether it would be subject wise, topic wise or full length test, it helped me to improve my numerical solving skills in all the domain of the subjects that are included in mechanical. It helped me to cope up with the new numerical type of problems which normally students face difficulty in solving in first go. So it helped me to cope up with this type of numericals, and also I got to know through different multiple choice questions, multiple select questions which are now